So we're going to take a look at another example with variables, and we will try and find the GCF kind of using the shortcut. So I'm still going to use my factor trees for 60 and 75 because I can see 5 as a common factor, but maybe there's a number that's greater than that that goes into both of them. So 60 is 6 times 10, 6 is 2 times 3, 10 is 2 times 5, 75 is 3 times 25, 25 is 5 times 5. So when I look at my lists, I notice that they have a 3 in common, in addition to a 5. So my GCF will be 3 times 5. And then looking at my variables, remember the shortcut is to grab that exponent that's the smallest. So versus a to the 4th versus a squared is a smaller exponent. And looking at my b's, I have b cubed and b, the smaller exponent is a single b. So simplifying this, 3 times 5 gives us 15, a squared b is our GCF. So we've got an application problem with our GCF. We've got a phi ed teacher who wants to divide 15 male students and 12 female students into teams, each with the same combination of male and female students with no one left out. So it's the greatest number of teams that can be formed. Now when we see this word greatest, I'm thinking I probably want the GCF. So I'm going to find the GCF of 15 and 12. And that would be 3. So what I'm going to do is, circle these first so we can see that we've got a 3 in each list. So I'm thinking that since I have a 5 left over with the 15, I'm probably going to end up with 3 groups. So my first group, to double check myself, I would have 5 males, and then the leftover was 4 for our 12. 4 times 3 gives us 12, so 4 females. My second group, I would have another 5 males and 4 females. And my third group, I would have another 5 males and 4 females. So that would give me a total of 15 males and 12 females in those 3 groups. Alright, so we're going to start LCM. And again, just starting by looking at numbers. So we've got the least common multiple of 8 and 12. We're again going to find the prime factorization. We've seen this a couple of times today, so hopefully you have that memorized. And 12, 4 times 3, 4 is 2 times 2. And we are looking for what they have in common, because what they have in common, we don't need to double multiply, so to speak. So they've got 2 times 2 in common. So we will just use a 2 times 2 from one list, and then we have to use the leftovers from each list, times 2 times 3. So our least common multiple will be 2 times 2 is 4, times 2 is 8, times 3 is 24. So we can double check ourselves. Does 8 go into 24? Yes, 8 times 3. Does 12 go into 24? Yep, 12 times 2. Some of you may have seen finding the least common multiple by writing out lists, and you can do it that way if you learned it and you prefer that method. So what I would recommend is starting with the bigger number, 12, and just multiplying it until you run into a number that you know 8 goes into. So 8 does not go into 12. 12 times 2 is 24. 8 does go into 24. So while that may seem like the faster method on this one, it might not always be the fastest method. So let's take a look at 5 and 9. Well, 5 is prime. 9 is 3 times 3. Since they had nothing in common, we would multiply our 5 times 3 times 3, or 5 times 9 is 45. And finally, we're going to take a look at how to find the least common multiple with variables. So I'm going to, again, start with my factor tree for my numbers, 14 and 21. So they've got a 7 in common, so I will only multiply one 7 times the 3 and 2 that were left over in the other lists. And for the least common multiple, think about this the opposite way you think about the GCF of variables. You want to grab the one with the greater exponent, because x goes into x squared, but x squared does not go into x. So you can think about that again by writing them out They each have an x in common, so I'm going to write down 1x. And then, oops, I shouldn't have said that, underline, that x is left over. So as you can see, I end up with the x times x. And same thing, I have a y left over, so I'm going to multiply by the y as well. So 2 times 3 gives us 6, times 7 is 42, x times x is x squared, y. This is the last example. I know the video is past 5 minutes, but I'd rather do a 6-minute video than a 5-minute and a 1-minute video. So let's take a look at this. Hamburgers are sold in packs of 10, and buns are sold in packs of 8. How many packs of each do you need to buy to have the same amount of each? This is kind of a problem when we go grocery shopping. So we're going to do this as the least common multiple. We have to buy at least 1 pack of each, but 8 and 10 aren't the same number. So we're going to do least common multiple. Quickly our factor trees. They have a 2 in common, so I'm going to take a 2 times the leftovers in each list. 2 times 2 gives me 4, times 2 is 8, times 5 is 40. So you would need to buy 40 hamburgers, but they're sold in packs of 10. So in order to get 40 hamburgers, I would need 4 packs. And in order to get 40 buns, since buns are sold in 8, I would need to buy 5 packs. Alright, and finally the you try problems. Make sure you get these down and have them attempted before you walk into class tomorrow.